In this video, we're going to be working with intercept form of quadratics. So let's first begin by introducing ourselves to intercept form. This is what we call intercept form. And it's called intercept form because we're given the x-intercepts, in this case P and Q. So here we can see that our x-intercepts are P and Q. Now our axis of symmetry, sometimes referred to as our AOS, is halfway between the P and the Q. So basically we're able to say that our axis of symmetry equation is x equals P plus Q divided by 2. Now the graph is going to open up when A is positive, and it's going to open down when A is negative, and that's not new, that's kind of an older thing. So up when A is positive and down when A is negative. So notice here on our graph, our picture, here's a picture of P and Q, so those are our x-intercepts. Notice that our axis of symmetry is halfway between those. So this is our axis of symmetry, and there's our equation for that. Now we're going to graph and describe the domain and the range of this given function. So again, remember to identify your form. So this is intercept form, which is what we were just using, or rather what we were just talking about, which means that we have an A value that we need to find, a P value that we need to find, and a Q value that we need to find. Our A value is in the front. So here we only see a negative sign, which tells us there is an imaginary 1 there. So our A value is a -1. Our P value is going to be the opposite of this 1. Now why is it the opposite? The reason that it is the opposite is because up in our equation, notice that they had minus signs there. And here we see a plus sign, which tells us that that is a -1. Our Q is just going to be a 5 because we have the minus sign that we were expecting. From here, the next thing that we want to do is find our axis of symmetry. And in order to do that, we need to add our P and our Q. So remember that our equation was the P plus the Q divided by 2. So we're going to take our P and we're going to add the Q to that and then divide that by 2. So here we're going to have an axis of symmetry of 2. We can see that our graph is going to open down because our A value is negative. And so now we're ready to graph. So we'll go ahead and we will put our x-intercepts at -1 and +5. And we'll graph our axis of symmetry at 2. And so that's our dotted line. And so that brings us to our next big thing. So notice that here we've done our first step. We identified our A, P, and Q, decided if the graph opened up or down. Then we found our axis of symmetry. Well, the third thing is we need to find our vertex. We need to find our vertex. I'll do that in purple as well. So our vertex means that we're going to need to take our equation. So we're going to take our equation, and everywhere that there is an x, instead, we're going to put our axis of symmetry because that's what x equals. So we're going to plug that in. And that is going to give us, and so that's going to give us a value of 9. So that means our vertex is going to be the point 2, 9, where our 9 came from plugging our 2 into our vertex, and our 2 is our axis of symmetry. So we'll go ahead and we'll plot that point, so 2, 9. And it looks like we're don't really have enough room there unless we lowered our graph. So what we might need to do is move this down a little bit since we're having to go quite so high up. So we'll go ahead and we'll re-put on our P and Q. So P and Q. And now we'll do our vertex at 2, which should be on our axis of symmetry, and up to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then to finish our graph, we will come from our vertex through our x-intercept and down each side. And then the last thing it asks us to do is to describe the domain and the range. So our domain, because it's a quadratic function, our domain is going to be the x equals all real numbers. And here our range, we're saying that y, now because our graph opens down, okay, because it opens down, we have a maximum value. So y must be less than or equal to the y value that our maximum is at. And that's all the way up here at the number 9. So y must be greater than 9. And again, we get that number from the y of our vertex. And so that's how you can graph using intercept form.